I'm sharing my screen. Wait for some time. Let me stop share. Wait. Let me show. Yesterday we learned about FCFS scheduling, right?
Yes, ma'am.
I didn't explain FCFS scheduling in detail. I just said that I will explain it in the next class, right?
Yes, ma'am.
Now, if we explain FCFS scheduling, let me explain FCFS scheduling with you first. Then we will start. Now I am writing something. Wait. Suppose there are three processes. P1, which will take 5 seconds to execute. This process P1 will take 5 seconds to execute. Okay. Now there is one process called P2 which takes 3 seconds to execute. And there is another process P3, which take 9 seconds to execute. These.
Yes, sir.
Hello? Hello?
Yes, ma'am.
Okay, so I was disconnected. I was sharing my whiteboard. If I share my whiteboard, first of all, there is process P1. Suppose there is one process P1. There is another process called wait. There is another process we call P2. If we consider three processes and we want to execute FCFS scheduling to these three processes, then there is another process, say process P3. So there are three processes, P1, P2, P3, and let me write something. Process P1 will take 5 seconds. Process P2 will take 6 seconds. And process P3 will take 9 seconds to execute. In FCFS scheduling, if we schedule these processes with the help of FCFS scheduling, what will we do? We will shift these processes, or we will change the state of the processes from ready to running with the help of a scheduling. I was getting disconnected again and again. I have problem with my connection. So if I was explaining something, that has also gone. Suppose I will not share anything. I will just explain. If there are, say, 3 processes, process P1, P2, P3, I was just telling you that process P1, they will execute in order or when as the process comes in the queue, they are served or they are processed as FCFS, first in, first served. They are processing is being done in FCFS pattern, first come, first serve pattern. The scheduling, since each and every process requires processor's time, so scheduling is being done by following FIFO policy, first in, first out policy. Is there any confusion regarding FIFO policy? No confusion, I think.
No, ma'am.
First in, first out is a simple algorithm. And also we prepare one diagram for allocation, which is called NAT chart. How does this diagram look like? I will just draw it. Actually, I have drawn earlier, but since I was getting disconnected, so it's creating a problem for me. This is the NAT diagram, P1, P2, and P3. You can write P1. Then if, say, the processes are allocated based on some algorithm, if P1, P3, and then P2, then we can write it in this form also. And what is this called? This type of diagrammatic representation is known as NAT chart. This is the diagrammatic representation. Is it okay? Diagrammatic representation, how does it look with the help of NAT chart? Now I want to share my screen and I want to show the PowerPoint presentation. Today we will learn about other 2 CPU scheduling processes, shortest job first and priority scheduling. Listen carefully, shortest job first scheduling. This algorithm associates with each process the length of the processor's next CPU burst. If there is a tie, FCFS is used. Suppose this scheduling algorithm is based on the time which a process requires to execute. How much time the process requires to execute, this is the time. So when a process, when a process requires to execute and the shortest time it takes is, say, 5 milliseconds. If there are more than one process which want to take 5 milliseconds, then how you will how the CPU will decide that which process will be allocated the processor first. It will run FCFS policy, first come, first serve. If there are 2 processes, each having equal length, then the processor being allocated is FCFS policy. Shortest job first algorithm is optimal. Why it is optimal? Because it gives minimum average waiting time for a given set of processes. It gives minimum average waiting time. This is the example P1, P2, P3, P4. These are the burst time 6, 8, 7, 3. What is burst time? Can anyone explain? What is burst time?
The time taken by a process to complete.
Yes, the time taken by a process to complete is called burst time. This means process P1 will take 6 seconds, process P2 will take 8, P3 7, and P4 3. So, if we calculate waiting time, look carefully, if we calculate waiting time and if we follow FCFS policy, then what will happen? 0 plus 6 plus 14 plus 21 divided by number of processes, that is 4, gives us 10.25. Are all of you able to understand how FCFS average waiting time is calculated? Zero is for P1, for P2 it is 6, for P3 it is 14, for P4 it is 21. How this calculation is being made? No answer. Then I will unmute participants and ask. Devmallo Sharkar, you want to say something? Devmallo Sharkar, you want to say something regarding 0 plus 6 plus 14 plus 21? Shourabh Kaur, roll number 23. No answer. Trisha Dash, at least let me know whether you have understood or not. If you remain silent, I couldn't understand whether you are listening or not. Trisha, have you understood?
No, ma'am.
No. Then at least if you are not able to understand, just tell me, madam, we are not able to understand. Or say that, madam, we have understood. Don't keep silence. Arun, roll number 4. Have you understood? No. You have not stopped me and asked, madam, please explain. Suraj, have you understood?
Yes, ma'am.
Explain.
Ma'am, first come, first serve. First, we will calculate the time as the process goes on. First, we will take the time as P1. Initially, it is 0. Then first, we will take the process time as P1, which is 6. So 0 plus 6. Then for calculating the second process, it will continue as 6 plus 8, which is 14. So 0 plus 6 plus 14. Again, it will calculate the same 6 plus 8 plus 7, which is 21. So 0 plus 6 plus 14 plus 21. And the last process is not calculated because it will complete.
Good. And what about SJF?
SGF is a bit confusing. I'm
You're a little bit confused.
considering the pattern. Yes, ma'am.
Good. Very good, Suraj. You have explained FCFS in a very correct manner. So once again, I am explaining if you consider FCFS policy process, since FCFS policy is based on first come first serve, irrespective of the burst time, that means irrespective of burst time means it doesn't taken into consideration the burst time. So process P1 takes 0 seconds or 0 milliseconds to start executing, because as soon as process P1 comes, There is no other process, so it is allocated the CPU, so its waiting time is 0. Then process P2. Process P2 came just after process P1. So process P1 has to wait for 6 seconds. Why? Process P2 has to wait for 6 seconds. Why? Because process P1's burst time is 6 seconds. So process 2 waited for 6 seconds. Then process P3. Process P3 waited for 6 plus 8, that is 14 seconds. Then process P4. Process P4 waited for 6 plus 8 plus 7, that is 21 seconds divided by 4. Similarly,
4 দিয়ে ডিভাইড কেন হলো?
অ্যাভারেজ বার করতে হবে, অ্যাভারেজ ওয়েটিং টাইম বলা আছে না, দেখো টার্মটাই হচ্ছে অ্যাভারেজ ওয়েটিং টাইম। তো অ্যাভারেজের ফর্মুলাই তো হচ্ছে যে নাম্বার অফ আইটেমস ডিভাইডেড বাই n, তাই না? তাই জন্য 4 দিয়ে হলো। যদি 6 থাকতো, if there are 6 processes, then in the denominator we could have written 6. Now if we look at SJF, SJF এর টাইমটা কেউ বোঝাতে পারবে কিভাবে 3 plus 16 plus 9 plus 0 হলো? 3 is for P1, 16 is for P2, 9 is for P3, 0 is for P4. No, anyone not able to understand? It is the same logic in which FCFS is being calculated. In FCFS, the difference is that in FCFS, the job which came first in the queue was considered, and is as shortest job first, the shortest job is taken into consideration. Like P4, when all the processes entered in the ready queue, then average waiting time for the smallest process for P4. From P4 we are starting, it is 3. Then which one is the next job? After 3 comes 7. Then comes, sorry,
6.
after,
Ma'am, 6.
yes. After 3, then 6, then 7, then 8. This is the, that means P4 plus P1 plus P3 plus P2 divided by 4. P4 is 3, and then you add on the calculation. After that you go on adding the calculation. Sorry, if you look in process P1 is for process P4. P4 is the shortest one, so 3 milliseconds is allocated, and then you go on adding one by one, and then divided by the number of items, you will get the average. What I will do, I will provide you with this lecture, then you will be able to find out.
Ma'am, there is a question of how did 16 comes first?
It is the waiting time of process P2. Okay, it is the waiting time of process P2. It waited for 16 seconds. Look, the waiting time for process P4 is 0. Why the waiting time for process P4 is 0? Because process P4 was the smallest process. So as soon as it comes into existence and in the queue, it is allocated. So process P4 is having 0 milliseconds. Then the next process is process P1. It will wait for only 3 milliseconds. Why? Because process CPU is allocated to process P4, and which is having 3 milliseconds, or which will take 3 milliseconds time. So P1, for P1 the value is 3.
Okay, ma'am.
Now you are able to understand. For P4 it is 0. For P1 it is 3. For P2 you calculate it in the similar manner. The waiting time,
ম্যাম
because
16টা কিভাবে আসছে বুঝতে পারছি না।
16টা কি আগে তুমি বলো 3 টা কিভাবে এলো?
P4
3 P4 P4 নয়, এখানে লেখা আছে না 3 plus 16 plus 9 plus 0. This shows the waiting time of individual process. For P1 the waiting time is 3. For P2 the waiting time is 16. For P3 the waiting time is 9. For P4 the waiting time is 0. এবার তোমরা বলো for P4 why the waiting time is 0?
ম্যাম এটা কি কোনোভাবে মাইনাস হচ্ছে?
মাইনাস টাইনাস কিছু হচ্ছে না। মাইনাস কেন হবে? এটা হচ্ছে shortest job first algorithm. What is shortest job first algorithm? As soon as
4টা সবথেকে ছোট বলে কি হচ্ছে, 3 আছে বলে ওর জন্য কি শর্টে?
হ্যাঁ শোনো কথাটা, suppose there are 4 processes P1 P2 P3 P4 and the burst time is given. So as per shortest job first algorithm, average waiting time, you need to add up the waiting time of all the processes. In a queue there are 4 processes. The CPU will select the shortest job first. The CPU will select P4, process P4. The CPU will select process P4. Burst time of is 3 milliseconds. So process P4 is allocated the CPU. So the waiting time of process P4 is written as 0. Is it clear? Not getting answer. Hello. Process, why for process P4 it is 0? Because process P4 is the smallest process, and as per shortest job first algorithm, the process which is having the shortest time is allocated the CPU first. So process P4 don't have to wait for the CPU allocation. Process P4 just came and CPU allocates process P4, or CPU starts executing process P4. So process P4 don't have to wait in the waiting queue. Why do you don't have to wait? Because it is the smallest process, and as per this algorithm, the algorithm will choose the smallest process first. So process P4 is chosen. That means process P4 don't have to wait for any seconds or any time. So the waiting time for process P4 is 0. As simple as that. Not getting responses from your side?
আমি বুঝেছি।
বুঝতে
Yes,
পারছো?
I'm understood.
If now we now this is for process P4. Now if we look for which one next, which process will be executed? Next process P1 will be executed. If process P1 is executed, then what will happen? Process P1 has to wait for 3 milliseconds. Why it will wait for 3 milliseconds? It will wait for 3 milliseconds because the CPU is allocated to process P4, which is taking 3 milliseconds. So once it gets executed, once P4 gets executed for 3 milliseconds, only then process P1 will start executing. If say process P1 or process P1 will start executing after 3 milliseconds, which is the time taken by process P4. Is it clear? বলো process P1 কেন 3 milliseconds wait করবে, বোঝা গেছে?
Yes, ma'am.
Only one answer. Moithili, বুঝতে পেরেছো মৈথিলি দত্তগুপ্ত? Have you understood?
হ্যাঁ ম্যাম।
Good.
হ্যাঁ ম্যাম। হ্যাঁ
হ্যাঁ বোঝা গেছে তো? আচ্ছা এবার দেখো,
হ্যাঁ
এবার যদি আমি প্রসেস P2 এর ওয়েটিং টাইমে আসছি না, বিকজ প্রসেস P2 will get executed at the last. Process P4 gets executed, then process P1 gets executed. After that, it will execute which process? It will execute which process?
প্রসেস P3।
Process P3. That means it has to wait for 3 plus 6, 9 milliseconds. 3 milliseconds process P4 has taken, and 6 millisecond process P1 has taken. So 3 plus 6, 9 millisecond process P3 has to wait. Is it clear?
ma'am.
Nehapal, have you understood?
yes ma'am.
Good. Now we look at process P2. Process P2 has to wait for all the 3 processes to get complete. Once process P4 finishes execution, then process P1 finishes execution, then process P3 finishes execution, only then process P2 will be able to execute. So process P2 has to wait for 16 milliseconds. Why? Because 9 plus 7, that comes to 16. If you go on adding all these, then it comes to 16. Is it clear? Why 16 milliseconds?
এবার বুঝেছি।
বোঝা গেছে? সবাই রেসপন্ড করো, না বুঝতে পারলে কিন্তু অসুবিধা হবে। সবাই বুঝতে পেরেছো? কেন এই পরীক্ষায় এগুলোর অঙ্ক আসে, তো this is important. Okay, now acha ebar if we look at the comparative study, what we find out? That the average waiting time of FCFS is more as compared to average waiting time of shortest job first. Shortest job first has to wait for 7 milliseconds, and for FCFS it is 10.25 milliseconds. That means shortest job, which one is better, short SJF or FCFS?
FCFS।
Yes,
FCF.
FCFS is better.
SJF. Ma'am, SJF.
SJF.
Why SJF is better?
Ma'am, because it is taking less time to complete
Yes,
the
it's
process.
time. It's shortest.
Waiting time
That's
is,
why.
yes, waiting time is less. That means it process execution will get completed. Now there are 2 schemes. Shortest job first, there are 2 schemes. One is preemptive, another is non-preemptive. In non-preemptive, once CPU is given to the process, it cannot be preempted until it completes its CPU burst. And for preemptive, if a new process arrives with CPU burst less than the remaining time of current executing process, this scheme is known as shortest remaining time first. Let me explain this. What is the term preemptive and non-preemptive means actually? Suppose there are 3 processes. There are only 3 processes: process P1, process P2, process P3. Process P1 takes 10 milliseconds. Process P2 takes 2 milliseconds, and process P3 takes 5 milliseconds. Earlier, when there was no process in job queue, then only process P1 was there. And CPU started executing process P1. So when it started executing process P1 for 10 milliseconds, after 2 milliseconds, another process P2 came, which is having a burst time of 2 milliseconds. Process P1 was executing in CPU for 2 milliseconds, but for its completion, it has to take 8 more milliseconds, which is greater than the process P2, which will take only 2 milliseconds to execute. Is it clear what I am saying?
मैम एक बार समझिएगा.
Okay. Non-preemptive scheduling means CPU will stop executing the processing of one process and will jump to another process if the burst time of that process is less than that of the executing process. So if there are two processes P1 and P2, suppose CPU starts executing process P1 having 10 milliseconds as time, 10 milliseconds as burst time. It was executing, 1 millisecond is at executed, 2 milliseconds is at executed. Then CPU found out that there is another process which has came up and the burst time of that process is only 2 milliseconds. At that time, at this moment, CPU find out that process P1 still require 8 milliseconds to complete. It has only executed for 2 milliseconds. What will CPU do in case of preemptive? CPU will move out the process P1 in another queue, which is called waiting queue. Since P1 require 8 milliseconds for its completion, whereas another process P2 has came, which only require 2 milliseconds. That we can say that CPU has preempted process P1 and executed process P2 because the time taken by P1 to complete the total process is greater than the time taken by process P2 to complete. What happened? Have you understood?
Yes,
Yes,
ma'am.
ma'am.
Okay, good. This is preemptive, and one is preemptive, another is non-preemptive. Preemptive means you can switch between one process to another process. But in case of non-preemptive, once the process is allocated CPU, it will complete its execution, and only then another process will be executed, whatever be the burst time. This is the diagram. I will give you these video lectures. Just go through them. And if there is any confusion, you can come back. There are processes P1, P2, P3, P4. So you can find out the arrival time and burst time also. Try this at your home when I will give the video lecture. Then if there is any confusion, you can ask. This is another diagram. Earlier was for non-preemptive, and the same processes, process P1, P2, P3, P4 was for preemptive also. One preemptive example was taken, and for another, one was for non-preemptive, where you can find out continuous execution P1, P3, P2, P4. But in the next diagram, you can find out P1, P2, P3, P2, P4, P1. You will find out that there is a breakage. After process P1 executed for 2 milliseconds, it find out that it still has 5 milliseconds to complete. But in the meantime, process P2 has arrived, whose burst time is 4 milliseconds. So process P2 is given the CPU time. Advantages of shortest job first algorithm. These are the advantage. Minimal average waiting time. You have seen it, the comparison with FCFS also. SJF algorithm is used frequently in long-term CPU scheduling. These are disadvantages. Difficulty in knowing the length of the next CPU request or burst. SJF algorithm cannot be used for short-term CPU scheduling.